Welcome to the AI Research Roundup. I am Alex. Today, this post from Google Research, published May 14th, 2025, Deeper Insights into Retrieval Augmented Generation, the role of sufficient context, caught my eye. It explores how Retrieval Augmented Generation, or RAG systems, which feed LLMs external data to answer questions, can be more accurate. The authors introduce sufficient context, meaning data that's not just relevant, but truly enough to answer fully. This helps cut down on hallucinations. That's when models invent answers. They've built an autorator for this and applied these ideas in a new LLM re-ranker in Vertex AI. Alright, so this first figure gives us a nice visual overview of how these retrieval augmented generation systems actually operate. You see the user poses a question. This then goes to the LLM. The system performs a retrieval step, pulling in external information, which is the context. The LLM then processes this context along with the original question to generate a response. And importantly, the diagram shows the possible outcomes: a correct answer, an I don't know if it's unsure, or a hallucination, which is that incorrect made-up information we want to avoid. Okay, so to actually use this idea of sufficient context, the researchers first needed a way to automatically determine if a given piece of context is sufficient for a query. This figure, titled Evaluating Classifiers for Sufficient Context, shows how well their automatic rater, or autorator, performs. The bars represent different methods, and the height shows their accuracy in judging sufficiency compared to human labels. We see Gemini 1.5 Pro, especially with a one-shot prompt. That's where you give the model one example to guide it, achieves 93% accuracy. This is better than zero shot, with no examples, and also outperforms fine-tuned models like Flame. Fine-tuning means taking a pre-trained model and training it a bit more on a very specific task. Alright, so building on the autorator's strong performance we just discussed, particularly when using effective prompting strategies like that one-shot example, this diagram, titled Autorator for Sufficient Context, actually shows us how this automatic rater is constructed. First, an input query goes through the standard Retrieval Augmented Generation process to get the relevant context. Then, this query and its retrieved context are fed to another LLM, which serves as the rater. This rater is guided by carefully designed prompts, which are essentially detailed instructions and examples given to the model, including that one-shot example we talked about, to help it decide if the context is sufficient. Finally, it outputs a simple true or false, a binary label, indicating whether the context has enough information. Okay, so using this autorator, the researchers then looked into how often different standard benchmark datasets actually provide sufficient context. This chart, titled Measuring Sufficiency by Context Length, shows us exactly that. On the y-axis, we have the percentage of examples with sufficient context, and on the x-axis, three different datasets: Fresh QA, Hotpot QA, and Musique. The different colored bars show context length and tokens, which are basically bits of text, like words or parts of words. We can see Fresh QA has a much higher sufficiency, around 77%, compared to Hotpot QA and Musique, which hover around 45%. This highlights that the source of the context really matters. So after seeing that some datasets lack sufficient context, this next figure offers a detailed analysis of how three different LLMs behave across four types of retrieval augmented generation context. We're looking at Gemini 1.5 Pro, GPT-4o, and the smaller open source model Gemma 27b, and their responses with no context, any context, sufficient context, and insufficient context. The pie charts break down responses into correct, abstained, or hallucinated. A really interesting and somewhat counterintuitive finding is that providing context, particularly insufficient context, often leads to more hallucinations. For instance, Gemma's hallucination rate skyrockets from about 10% with no context to over 66% when given insufficient context. This suggests adding context can sometimes make models overconfident rather than simply admitting they don't know. So, building on that challenge where providing context, especially insufficient context, can surprisingly lead to more errors, as we just discussed. These three charts here show a proposed solution, a selective generation framework. Each chart is for a different model. Gemini 1.5 Pro GPT-4o, and the smaller Gemma 27b, and they all plot selective accuracy against coverage. Selective accuracy, well, that's how accurate the model is on the questions it actually chooses to answer, and coverage is simply the percentage of total questions it attempts. Now, the key thing is the two lines. The gray line represents the model's performance using its own self-rated confidence score to decide whether to answer. That's P correct for Gemini and GPT, and P true for Gemma. The purple line shows what happens when you add the sufficient context signal to that self-rated confidence. And as you can see, for all three models, the purple line is generally higher. This means that by incorporating the sufficient context signal, the models achieve better accuracy for the same percentage of questions answered, essentially making smarter choices about when to respond. Alright, so that selective generation framework really offers a promising path forward for making retrieval augmented generation systems more reliable. The core idea here is that sufficient context is a much better target than just relevant context. It's fascinating that simply providing some context, if it's insufficient, can actually lead to more hallucinations. But, as we saw, tools like the Autorator, which can classify context efficiency with over 93% accuracy, and the selective generation approach can really help. That's all for this edition of the AI Research Roundup. I'm Alex, thanks for joining me.